Have you ever wondered why almost every deep learning classification model relies on cross-entropy instead of simpler methods? Today, we dive deep into the math and intuition behind this ubiquitous loss function. Cross-entropy is the standard for measuring the difference between two probability distributions. In simple terms, it calculates how far apart your models' predictions are from the true labels in a classification problem. Unlike mean-squared error, which works for regression, cross-entropy specifically rewards confident correct answers and heavily penalizes confident wrong ones. This forces the model to become more certain rather than guessing. Mathematically, it is closely related to the Kullback-Leibler divergence. It measures the inefficiency of assuming one distribution when the true distribution is different, acting as a direct measure of information loss. When we train, the gradient of cross-entropy with respect to the model's output is simply the difference between the prediction and the target. This clean derivative makes optimization incredibly efficient for training deep layers. Efficiency is why it is ubiquitous in modern deep neural networks. It allows us to train models on massive datasets, like ImageNet, ensuring they make accurate and confident predictions across thousands of categories. In summary, cross-entropy combines information theory with optimization to provide a robust, mathematically sound way to teach computers to classify data correctly and confidently. Now you understand the deep math behind classification success. Which loss function have you used most in your projects? Let me know in the comments and subscribe for more technical deep dives.